Okay, so today I'm going to be talking to you about machine learning, the biases present within it, and hopefully some ways we can learn to avoid them. So first of all, I just want to give a brief introduction on machine learning. So machine learning is essentially enabling computers to make their own decisions in a way that hasn't been hard-coded or explicitly accounted for by the developer. Instead, machine learning algorithms take in some data, do some pattern recognition and a bit of maths, and learn their own decision-making strategies, which personally I think is pretty cool. Now, this could be as simple as learning to map blood pressure to lifespan, where the data would simply be a long list of blood pressure readings and lifespans. Or it could be as complex as learning how to drive, where the input data you need is a vast array of information from LiDAR sensor readings to fuel readings. Now, this all sounds pretty good, but in the real world, applications are never this simple, and usually they have their fair share of complications. Specifically today, I want to talk about bias and how it can affect these machine learning algorithms. So to see how this can occur, let's consider the blood pressure example from earlier. In the real world, it wouldn't be as simple as simply mapping from blood pressure to life expectancy. Organizations that would be most interested in this type of problem, which would be insurance companies, want the most accurate data as possible concerning their clients and their health statuses. To do so, you would need as much data as possible. And not only is the volume of data important, so is its quality and its depth. So blood pressure isn't the only thing that affects your health. So we should also include things like cholesterol readings, whether you smoke or not, how much you exercise, your age, and many more factors. So what ends up happening is the developers of these algorithms include literally all the data they have on the clients. And one of the cool things about machine learning is it can actually learn which of the factors are more important and which ones can be ignored, and will filter them out by itself. So if we lived in a perfect world and if we could collect perfect data, then maybe this would work perfectly. But in reality, the insurance company is not perfect and their data is not perfect. So for example, if they include all the data they possibly can, then certain groups within their data would have a lower relative proportion, and this might cause bias. So for example, let's say the company has 100 clients, and of those clients, let's say they have 5 clients with red hair. And then let's say 3 of those redhead clients have poor health indicators. A machine learning algorithm might incorrectly learn that having red hair is therefore an indication of a lower life. Now, personally, I would disagree, but that might just be my own bias. So that was just one example of how bias can occur in machine learning. Specifically, that was a general example of data bias, which is when the data used to train the algorithm does not accurately reflect the data used in the real world in some way. So here, the inaccuracy was the proportion of sick redheads in our dataset did not accurately reflect the proportion of sick redheads in the real world. More specific types of bias could include label bias, where an algorithm can learn or inherit its bias from the data that it trains on. So an example of this would be a movie ranking AI, where if it is predominantly trained on the reviews from just one reviewer or just one organization or reviewing site, then the algorithm could express the same biases that were found in that person's or in that organization's reviews. There's also sampling bias, which occurs when your data is not a random sampling representation of the entire population. So for example, if you are wanting to write an AI to analyze user reviews for your website, you might already be a victim of sampling bias before you even start, because the type of person to leave a user review on a website probably doesn't accurately represent the entire population of your users. There's also feedback bias, when an algorithm uses its own generated data to learn from. This might sound pretty weird, but it is actually used quite often for problems where there isn't a lot of data available, especially for reinforcement learning algorithms. So an example of this would be a chess AI that learns by playing itself over and over and over again and learning from the results of those games. So if the AI started with an inherent bias initially, either from a random starting configuration or by first training on human data, then that bias could be amplified throughout these games and the entire training process. Now, these are just a few of the types of biases that can occur within machine learning, and it's important to note that these are often interconnected and can have a lot of overlap between them, and they require some combinations of methods in order to address them. So how can we address them? Let's take a look. So in my opinion, one of the most important things we can do as developers is to be honest. We can't always control where we get our data from, but what we can do is accurately and honestly detail our data and its origins, if for nothing else, then to encourage a sense of trust and accountability in the machine learning community, which I think is sorely needed. Also important is proper analysis and processing of your data. Identifying and explaining any underlying biases in the data is necessary, even if you don't plan on addressing them. When processing your data, it is also important to understand the methods that you are planning on using and how they might influence your results. From your sampling methods to any cleaning methods you use, ironically, things you do to reduce the amount of bias could actually add biases of your own. Auditing of your AI is also very helpful to identify any biases or other issues present within it. Performing regular periodic audits is very important depending on the type of algorithm and its application in the world. So audits typically involve performing or assessing your AI's performance on different groups and demographics and taking corrective actions where necessary to address the bias. And finally, your choice of machine learning algorithm is also very important. Certain algorithms are much better suited for different types of data, and the right algorithm can help more than any data processing can. In addition, you can actively develop algorithms to counteract bias, for example, by adjusting the hyperparameters or introducing certain fairness measures to prevent bias towards any individual groups within your dataset. Once again, though, we must be careful that any measures we take to reduce bias do not also introduce additional biases of our own. So hopefully I've helped you to understand bias and its role in machine learning a little bit more and some ways that we can try to avoid it. The world of machine learning is rich with opportunities, but it's also full of challenges. And by understanding and addressing bias, hopefully we can utilize its benefits while still ensuring fair and just outcomes. Thank you very much for your time.